Here is an extension to the problem sketch reciprocal of semicircle. I'm sorry for this typing error here, but the problem here is sketch reciprocal of semicircle, which is actually transformed. Let me use the word translated 2 units down. Okay, so I'll show you the function, then you'll understand why I added this statement here. F of x is equal to 1 over square root of 25 minus x square minus 2. So let's look into the function which is in the denominator, correct? Let's call this s of x. So s of x is equal to square root of 25 minus x square minus 2. Well, 25 minus x square is the equation of a semicircle. You can look into my video where we've done or sketched a graph of 25 minus x square root, right? And this function, which is a semicircle, has been translated 2 units down. So minus 2, right? So it's sketch reciprocal of semicircle translated 2 units down. And here I've shown you the graph of s of x. Okay. This is, for me, s of x, which is a semicircle translated 2 units down. So this point is minus 2, correct? And from here, this is minus 5 and this is plus 5, correct? So we can write this as 5 here and minus 5 here. So that is the function which we are dealing with now. I will suggest that we have 2 related videos on this. One is to sketch reciprocal of semicircle, and the other one is to find domain and range of this particular function. Now that problem comes in thinking type tips. So look into those videos also once you have gone through this video. Now here we will show you steps to sketch reciprocal from a given graph. Okay, we will not discuss this function as such because we have already discussed it in our other video. Okay, so as you know, if for a function s of x in this case we have an x-intercept, then reciprocal of this will lead to a vertical asymptote at that point. So first step is wherever we have x-intercepts of the denominator, at that point you draw vertical asymptotes, right? So we'll draw vertical asymptotes here. That's the first part. The second part is that the points which are at 1, so reciprocal of 1 is 1. So these are invariant points, correct? So they will remain there itself. So if there is 2 here, reciprocal of 2 is half, so we get this point, correct? And this is for us 3, so reciprocal of 3 is 1/3. So it will be like half was here, so we can assume 3 to be slightly below half, right? Let's say 1/3 here, right? And similarly from here, if we have 2 here, then we have a half. So we get the bottom part of our function, correct? And as you approach, let's say this is half, then the reciprocal of half will be 2. So we get these 2 points. So half and reciprocal is 2. Let's assume this is very, very close. And so let's say it is 1/4. So 1/4 reciprocal will be 4. So let's put it here. 1/4 reciprocal will be 4, correct? And we know that this is a vertical asymptote. So we can just extend this till the end. I hope it's clear what I'm doing. Now we'll just connect our points. and that becomes our reciprocal of part of reciprocal, right? So we are within the asymptotes, and we have already drawn the inner side. Outside you will see that we'll consider this graph and the point between our domain -5 to +5, and within this domain we see that we have a vertical asymptote at this point whose we have not really calculated, but we'll calculate it later. Now here this is 1, so 1 will be invariant, right? And this is -2. -2 reciprocal will be -half, so that will be -half for us. So this is -half, 1 remains at 1, and we know if we approach this, let's say this is 1/4, then that will be at 4. So let's say 1, 2, 3, 4. First, let me extend my vertical asymptote till the end of this graph, and let's say this point is 1/4, then it will be at -4. So let's say this point here, correct? So we can now connect these points. Is that okay? So from -2 we'll join 1, of course. -1 is invariant, and we connect. So we get a beautiful graph in 3 pieces, which represents reciprocal of S of x, or the graph of f of x. Do you see that? That's how we find. And one exercise which is left for us is to find what are, after all, the vertical asymptotes. So to find that, we can equate denominator to 0. That's the way to find vertical asymptotes. So let's do it. So we'll equate square root of 25 minus x squared minus 2 equals to 0, correct? So we'll take 2 this side and square it. So first we'll take 2 that side, equals to 2, and now we'll square it. So we get 25 minus x squared equals to square of 2 is 4, right? And then so we will now take x squared here, bring 4 on this side, and then square root it, right? So we will do that part. So we'll say x squared, and we say 25 minus 4. 25 minus 4 is 21 for us. Is that okay? And square root of 21 is x. So we say from here x is equal to square root plus minus of 21. Is that okay? So this is what we get from our function. So we can write the equation of the vertical asymptote. So the vertical asymptote becomes x is equal to square root of 21, and here x is equal to minus square root of 21. Is that okay? So that is our vertical asymptote, and this point is plus minus, this point is minus square root of 21, this point of course is plus 21 square root, correct? So that completes our problem. So it is actually a very difficult problem, but we try to simplify it for you and show you graphically how you can really plot the graph even without calculating the values, right? The good part here is that we could get all our points without actually using calculator, and that's the huge thing. Now, can you write domain range of f of x? That's a very good problem for you to solve. Think about it and write on your solution. You're looking at it, right? So let's complete it. So what do you think is the domain of this function? The reciprocal, f of x. So we say domain is equals to x, which belongs to real numbers because they are continuous lines, and x is actually between minus 5 and plus 5. So we can say x is greater than minus 5 and less than equal to 5, but x is not equal to plus minus square root of 21, because at 21 we have x-intercept of our s of x, semicircle shifted downwards, and a vertical asymptote, right? And how about range? So range is y belongs to real numbers. Here you see y is greater than or equal to this point, which is 1 over 3, correct? And here you see that y is less than minus half, because this was minus 2, right? So reciprocal of minus 2 was minus half. So we say y is less than equal to minus half. So that becomes our range, right? So now this completes our problem with most of the information which we need to understand our function f of x, which is reciprocal of a semicircle translated 2 units down. That minus 2 here, right? This minus 2 is translated 2 units down. Do you see that? So have a good look at it. Try to understand. And related with this, we have 2 other videos. One is to really sketch reciprocal of semicircle. The other one is very similar to what we have just now done, is actually domain and range of f of x, which is like this, okay? I hope you enjoyed it and learned from it. You can write your comments and share your thoughts about it. Thank you.